Hey guys, Mr. Mackey here. Now yesterday I introduced you to surds and I set you this challenge to try and find this in its simplest form using the two rules that I gave you. So let's start off with this bit, root 3 with the brackets 1 plus root 3. Now for this we're going to have to expand the brackets, so let's do it. So we do root 3 multiplied by 1, which gets us root 3, and then root 3 multiplied by root 3. Now, when we multiply two roots together, that's the same as doing root 3 multiplied by root 3, which becomes root 3 times 3. And that gets you root 9. Now, root 9 is a square number. And what's root 9? 3. So all you do whenever when you're squaring two roots together is you just get rid of the root. So that's that bit done. Now the plus 27. Now root 27, that's not a prime number, that's not a square number, sorry. So what we do is we turn it into two factors, with one of them being a square number. So we could do, well, there's not really any apart from 1 and 27, and 9 and 3. And 9's a square number. So that becomes 3 root 3. Now root 12, we could find two factors. One of them has to be a square number. So we can do 1 and 12, well, it doesn't work. 6 and 2, neither of them are square. 4 and 3, that works because 4 is a square number. So this becomes 2 root 3. I need to make that 3 a bit clearer. So, what's root 3 plus 3 root 3 minus 2 root 3? Well, root 3 plus 3 root 3 is 4 root 3. Take away 2 root 3 becomes 2 root 3. And we just got a 3 there. So the answer is 2 root 3 add 3. However, if you wrote it as 3 plus 2 root 3, it doesn't matter. They're exactly the same thing. Now we're going to be looking at surds again today in a bit more detail, looking at them as a fraction form. What do I mean? Let's get into it. Now, some problems we may end up with the denominator being a surd. And I'll admit, that's not very neat. I prefer to have my surds at the top, the numerator. Now, how we do this is we have to do something known as rationalising the denominator. Now, because surds are known as irrational numbers, we have to transform that into a rational number. Now, do you remember in the challenge recap that I did just now, how I got rid of that root sign? When you multiply that surd by itself, because root 2 times root 2 becomes root 4, 4 is a square number, so root 4 becomes 2. So when you multiply those two surd by itself, you have transformed it into a rational number. However, if we're multiplying the bottom number by a root, we have to multiply our top number by the same thing. So 1 multiplied by root 2 becomes root 2. And root 2 multiplied by root 2 becomes 2. What have we just done? We have transformed our denominator into a rational number, hence rationalising the denominator. Doesn't matter if the numerator's now been turned into an irrational, because at the end of the day it's the denominator that we want to sort out. So, this is how we rationalise denominators. Let's look at another one. So, we have a surd as the denominator. Doesn't matter if we have one as a numerator, so we need to multiply it by itself. And then we do the same to our numerator. So root 5 multiplied by root 2, well, thanks to our multiplication rule we got here, that becomes root 10. And root 2 multiplied by root 2 just becomes 2. And we do nothing, we don't divide it by 2 or anything, because there's no rational numbers to divide by. And we rationalise the denominator. That's it. So cool, isn't it? Let's try it with this one. This time it's not root 2, it's root 3, because I thought, you know what, do something different. So, we multiplied by root 3, and we multiplied by root 3. So, 6 multiplied by root 3 becomes 6 root 3. Root 3 multiplied by root 3 becomes 3. And that's all we have to do. Or is it? I knocked the pen out of the way because I had to make a dramatic move. We have to simplify this because there's a 6 at the top and a 3 at the bottom. 3 times table. Come on, guys. So how many 3's go into 6? 2. We leave the root 3 there. and that becomes 1, so we just leave it like this. So, the actual simplified version of our answer is 2 root 3. Rationalising a denominator is quite straightforward. Once you understand, you just have to multiply them by itself. Now, let's move on to a challenge. So, your challenge for me is I want you to rationalise the denominator of this problem. What do you have to do differently this time? The surds aren't the same. How could we make them the same? Good luck. I'm looking forward to seeing what you've got. Let's bring on more of these surds for the last 2 days. But take care of this one, guys. See you tomorrow.